Welcome everybody to the next session of Lunch and Learn. Today we're going to be talking about variable MSE, just kind of the basics. I appreciate everybody if you can just abide by the code of conduct rules, keep videos on, keep yourself muted unless you're speaking. We do have a couple of key roles to talk about. Lee, could you do process monitoring and process confirmation?
Yep, I'm doing that. I'm just going to use that template that we generated in the past, Frank, just for use it as a rough guide.
That's perfect. And I'm looking for Bill. You said you could possibly do the monitoring of the chat room and keep us up to speed on what's going on. Mike, you're going to do some recording for us to get the participant type of view. All right. So I'm going to go ahead and start to share my screen, and we'll get started. All right, so I usually like to kick things off with spacer, safety and resilience. The first thing, yesterday we talked a bit about. Claire gave us some great ideas about how to just kind of relax in a stressful environment like working from home, and things get kind of out of hand. You find yourself meeting to meeting and getting stressed out. Just take a little time to sit back, breathe, and take a good deep breath, and kind of look around at some of the things in the room, and just think about those. I like to look at photos of friends and family and things like that. The other thing I think is just kind of touch base with people you lead or people you work with, and just kind of ask them how they're doing today. The purpose in the last session, Rochelle talked about the reason for Lunch and Learns, to try to keep everybody up on the topic of Lunch and Learns, and just kind of keep the idea of the Six Sigma tools for our green belts and black belts always in the forefront of their thinking, and provide a forum for us to discuss some of the bigger issues that come up. Okay. The agenda, we're going to kick off with the spacer and get into why we measure, talk a little bit about that. We do have a 6-minute breakout, and in your session I sent out earlier, I sent a few files. One of them is that breakout template, or you can take a screenshot of the breakout slide. I believe it's slide 6, and take that into the breakout rooms with you. Okay. We're going to then go into a little bit of analysis, just kind of an overview of how to look at our measurement system output. And primarily today we're talking about the variable measurement systems. I know we got some really good feedback in the survey about topics you'd like to cover in the next upcoming Lunch and Learns, and we'll definitely hit some of those good topics. Code of conduct, again, I said as before, if you can keep the videos running and keep yourself muted. I did hear a click. Bill, if you could kind of watch if somebody's not muted, just kind of remind them in the chat window. Expectations is that today what I want to do, is kind of get the juices flowing and people thinking about variable MSEs, but not necessarily going deep into some of the topics that we'll be discussing. We'll basically try to break up into the ideas that you really want to go deep into, and we'll set up Lunch and Learns on those in the future. So today is just kind of an overview thing. And the roles we talked about, Lee's going to do process observer, Bill's going to do chat monitor. I'm looking for a volunteer to to kind of document things as we go. Claire, can you do that for us?
You betcha.
All right, I appreciate. And so let's go ahead and get going. So I want to stress we really need to think about the reasons why we're measuring things, right? It's almost like take it back a step and say, okay, what am I measuring for? Or what are the business metrics I'm measuring? What am I doing with those? And there's two reasons. So the first one on this particular slide is about I'm trying to make sure that I can conform to certain requirements or specifications, right? We talk about the specs, and a lot of us have this, discussion about the goalpost and even goalpost. I think we use goalpost mentality as uh, one of the things we talk about early on in the green belt and black belt training, right? But the main thing is, can I make good decisions based on my product? Does it meet the customer specs or not, right? And so that's one classic, maybe we say a classic reason for measuring. And then the second reason is improvement. Why am I measuring? Oh, well, I'm doing a black belt project. I've got a designed experiment. I'm looking at the capability of my product, right? And I want to improve the capability. And normally, when we think about that capability discussion, now we've got variation into the mix, right? We're thinking about how much variation do I have? Does it fit? Does my process performance fit inside those customer specs? And if not, we have three ways to improve it. Can anybody kind of chime in? What are the three ways to improve the process and make my little chart down there look better or improve my capability? I'll give you a quick hint. There are three S's.
You change the specification, right?
Okay, so one of the ways, and I've been slapped a couple times for saying, yeah, change the specifications. Maybe those specifications weren't derived correctly, right? Maybe if those specs can be opened up, I can certainly improve my performance. That's good. Any other ones? Texas people?
Squashing.
Squish, yeah, squish or squash that together. I think in a prior discussion, we were talking about taking that distribution and squishing it down, reducing the standard deviation. And what's the third thing we can do?
I'll take that as well, but shifting.
Yeah, shift it, or my Texas reference is the boot scoot boogie, right? I think we had our black belts singing that one day in Houston. But can I scoot that mean of the process back over to the target, which is in the middle there? All right, good. So you really got to think about it. Improving, a lot of times I have to do a lot better job of measuring. I have to measure to tighter resolution, or I have to do a much better job to get really good data for improving the process versus just a almost go no go situation here. Very easy to measure whether I got a field goal in a game, but I better be measuring, my deviation from target in as a professional field goal kicker. Okay. So the first thing we're going to do is a little breakout for you to go in and talk amongst yourselves in the breakout rooms. I want you to establish your own team roles. So your own breakout facilitator. If you're going to present back a slide, we don't have a lot of time. You can certainly just take some notes. And who's going to be the spokesperson for your group when we come back together in 6 minutes? And because it's 6 minutes, because we're kind of short on time today, really get yourself a timekeeper assigned ahead of time. All right. And I'd like you to break out and talk about a couple key measurements, maybe that have been, running across your desk lately, that you wanted to talk about, discuss those, and talk about, whether you're trying to take that measurement to prove that you're meeting a specification, or are you using those measurements to improve the process? And maybe some discussions about that. Is there a resolution that's more important, or how are you approaching those challenges? And we'll come back to the main room and we'll do a quick outbrief. I'm thinking 30 seconds to a minute for each breakout group, and kind of talk about what are some of the key takeaways that you had from your breakout. Okay. Any questions on the breakout? Okay. We're going to go ahead and get you into your sessions. I'm going to go with 3 sessions per group. 3 participants per session per group. And I'm going to go ahead and hit the button if you're ready. So any questions? All right.
Well, I'm in breakout session 1. Gentlemen, how's it? There we go. Hi.
Hello.
Mike, are we able to hear you in breakout session 1? I heard you in the main room.
I'm talking now.
You are good. Okay. You guys are in good shape?
Yep.
All right. Sounds good.
I see the session timer up there in the upper right. Now I know what to look for. We've been in here 45 seconds and have done nothing. I guess we should pick some rules.
So who's got roles? Mike, I think you did a good job of facilitating yesterday.
All right.
You can be facilitator.
All right. We need a spokesperson.
I don't think we really need a slide maker, so we don't need that role.
How about Marty as the spokesperson when we're all done?
Got my vote. All it takes is what, 2 votes, and at least we got a tie then. So I think that we get our way. So Marty, you willing to do that? You're on mute.
Yep, Marty's the last one mute. And
yeah, that's fine.
All right, thanks, Marty.
Let's see, Ricky, timekeeper.
Perfect. I like that room. Okay. So we are 1 minute and 35 seconds in.
Oh, okay, you got it, Ricky.
So
all right.
The question, 2 things that we measure. Somebody, I don't see London. Maybe London isn't here.
I'm here. I just I hate having all the screens up, so I just don't open my laptop.
Okay. Well, then the first question is, name one measurement that has come across your desk recently that might be interesting to discuss.
I guess for one, it would be like the powder paint thickness that I'm working on for part of my rotational assignment. So I'm measuring the CPKs and PPKs for it.
Okay, so then the discussion is that a metric for the sake of production acceptance, or is this a continuous improvement type of metric?
Production acceptance, making sure that all our customers are getting exactly what they want and that the product's within spec.
Okay.
I think one of the interesting things is that some of my measurements at incoming or in production, they're all production. It's an acceptance, pass, fail, until you fail. Then you want to know, well, how much is it out? Can I waive it? How bad is it? And whoever's got to work on it wants to know, what are they going to try to improve? So a lot of these pivot. As soon as you have an issue, it'll go from pass, fail. It'll pivot to, I got to improve because I got a failure or a nonconformance. And
it's possible for one metric to serve both purposes.
Sure.
So if you're barely passing, but they all pass, then you don't care.
I don't think it's a don't care, but I think that you're going to handle it differently. You'll temporarily change the spec if it's a fraction of a percent out. You'll say, that's in the noise.
Okay. Let's choose a second metric that somebody may have been measuring recently. How about you, Brad?
I've got one of the things that we're been working on are dealing with surface measurements, so surface roughness and flatness. And both of those, I was thinking of that where it starts out as kind of a conformance to print. But we don't think that even when we're conforming that sometimes we get the results we want in terms of first pass yield. And so we're actually trying to look at improvement. And part of the improvement isn't necessarily to improve the measurement. We're actually looking at different measurements. So we're improving the entire specification. So we're kind of pivoting from conformance to an improvement, which is really going into a totally different measurement, not just the measurement system.
So we're 2 for 2
Trying to improve
now.
the product. You're trying to improve the product performance.
Correct.
Just at that time, keep, we just have about 1 minute again. Eh?
Okay, 1 minute, and then we'll summarize. So if there's some sort of distinction that Frank is trying to get to regarding the difference between measuring for production acceptance and measuring for continuous improvement, I don't know that we've discovered it yet. Is there an example of one where that would happen? Where what you measure to prove you're okay to the customer is not what you would measure if you want to make it better.
So Brad, the one you were talking about, you were saying that was not a customer driven.
We don't have any. Yeah, we don't have any measurements that are customer. I'll use the term customer defined. We develop our own specifications, and our customers are basically buying what we provide. Now they can be unhappy with what we're providing, so we need to pick the right measurements. But in the end, our customers don't define it for us.
So let's let, I think, Marty, you're going to do the breakout or the debrief, right? Do you have enough? Do you want to summarize before you go back?
So on the one with said London brought up for the paint thickness, that was primarily driven by customer acceptance, correct?
Correct.
Okay.
Yeah.
And then the Brad's example of surface roughness was more driven internally to improve product performance.
Yeah.
Okay.
But we do it as an incoming also, or a PPAP where it's a conformance to documentation. So that's kind of where I said that we're establishing.
Love that forced return.
Hey, everybody, welcome back. I'm glad you could all be on time. So let's go ahead and start with team 3, actually, session 3. If you'd like to have some platform time here, 30 seconds to a minute out brief. What did you discuss in your group? I heard a lot about what was it, air test monitoring when I stopped in for a second, but. Rochelle, can you?
Claire, we can't hear. Claire's our spokesperson, Frank, and we can't hear.
Oh, Claire. Okay.
Okay, I'm not the spokesperson. Thank you for trying to delegate that to me, Bill. But I was just scribing here. But what I heard was there was a lot of things about why they're measuring particular elements, and it's around spec set by the customer, and then also going forward, I believe, reading between the lines, to understand whether or not the current product meets some tighter future spec that the customer wants to have in place. They're measuring air test setting. It's an outlet pressure. It's a mechanical measure of mechanical valve performance. They got it set to a specific reading, 0.6, and they have some manual testing that's taking a lot of time and has error in. So they're trying to move away from that right now. So I'm going to hand off to the rest of the team there. Anything you want to add?
I think a third reason on why measure Claire was to calibrate.
Yeah, and I like that. I like that discussion. It kind of shows that measurements today, or a measurement system today, may not be good enough for tomorrow. That's great. Thank you, Team 3. Team 2.
Yeah, thank you, Frank. I'll be speaking for Team 2.
All right, thanks, Austin.
We started off talking about measuring the different places where data is stored. How many of them are there? How long is it taking to find that data? And then are they finding the accurate data when they look there? We then went on to talk about LISC, some concentricity, and some oil replacement times. And so a lot of the things we talked about were kind of both meeting that spec, but also kind of have that continuous improvement back behind that as well. Some things like getting to the market faster and just overall working to improve the business by making those measurements more accurate.
I like it. Thank you very much, Austin.
Thank you.
Great. Session 1, first group.
That's you, Marty. Marty's the leader.
I don't remember which. Mike, are we Team 1?
Yeah, that's us, Marty.
Okay, all right. So for Team 1, we were discussing two different measurements in our session. The first one was paint thickness, and that was primarily driven by customer requirements. And the other measurement we were discussing was surface roughness, and that was primarily driven internally from a product performance perspective. So like surface finish and flatness, things like that. And in fact, we were actually changing possibly changing to different measurements to try to, in the end, achieve better performance. So
I
two
like
different,
that.
one customer driven, the other one more, internally driven.
Okay, excellent. So thank you very much, everybody. I'm going to go ahead and get back to sharing my screen. That's probably not the one I want to share, is it? Sharing my big screen. All right. So excellent job with the breakout. Hope you got to, meet each other a little bit too. That's always kind of a good side benefit. So when we talk about systems, I want to really make this point. We really got to, it's getting ourselves out of thinking just in terms of, the gauge R&R that we might have seen in prior, books and discussion where we kind of focused on gauge R&R. But right now, I want us to really, circle back around and think about what we learned in class was measurement system is the entire system, right? And so I talked to many of you, right, about collecting the data, collecting the samples, maybe, right? The geologists in the room, you guys, hey, how do I collect that sample? What's the process behind collecting the sample? Then how do I analyze that sample, right? So the best way to identify measurement systems and opportunities is as you walk the process, as you staple yourself to the process being done, just ask yourself, where in that process are we making decisions or judgments, right? Any kind of place where we see that we're either collecting data, numerical data, or we're making some type of good, bad, or a ordinal scale decision. Write it down, add that to your process map. And then the topic today is measurement system evaluation. And we always want to go back and remember that measurement system evaluation is a study. It's a design study to try to glean really specific information out of this study to make decisions about your measurement system, right? And the whole idea, and I know I've pounded on this many, many times about representative operators. I don't just find any old person to go in and be part of the study. I want to have, the people of concern that normally do the process or would do the process if they had to fill in, maybe, right? And these parts or samples that I'm using, I have to really think about those as well. You know, those parts should be representative of the type of parts and the type of decisions I'm making. I know, you know, Brad had some really good comments in the prior session about, you know, how much variation should be in those parts. And my answer is usually representative, right? Sit down, think about it. What do I want to learn about this particular measurement system, and then design your study. Here's a simple study, a simple tree drawn. I've drawn 3 operators in my study. Okay, I'm using 3 operators. I'm using 5 parts, 5 samples in my study, and then I'm doing 3 repeat measurements. And repeatability, the only way I can get that repeatability is have the same operator measuring the same part multiple times. And that's going to give me the repeatability. And then I can study the reproducibility when I look at the different operators. And part variation, right? These 5 parts, if they're representative of the type of parts I'm going to be measuring in production or the type of samples I'm measuring production, they're going to give me an idea how much part variation exists. All right. Again, a reminder: always be there. Don't try to design the study and then throw it over the wall to somebody else to run or take measurements for you. I think most of us have been surprised when we've tried to run studies, any kind of study, without being there and being able to take those copious notes. And then I think a lot of people forget is to just, you know, when you do your analysis of your measurement system, practical, graphical, analytical. It's always important to follow PGA as you analyze. Practical, does the data make sense, right? What do you see in those numbers? You know, I've had problems where people maybe recorded in metrics and they should have been recording in inches. Make sure that you know, everything kind of makes sense. What's the resolution? Did we truncate? A lot of times I see people taking numbers off of their readings and removing them, actually losing that data. And sometimes the person we assign as the data collector, the data monkey, as I say, may have entered the information wrong. And if you blindly go into the analysis in your statistical package, you're gonna make mistakes just because of obvious issues that you would have found when you go through the practical analysis. Does anybody remember what ANOG means?
Analysis of good.
Analysis of good, right? And it's kind of the, you know, tongue-in-cheek kind of a process, but the idea is a very simple process: sort by Y and look for patterns in the different factors. And the factors in this case could be the operators. You know, one operator tends to be measuring on the high side or the low side. If you see it in the ANOG, you better expect to see it in the graphical and the analytical. All right. Next is graphical. I kind of focus on this the most, and in class you probably remember we had a flip chart where items 1 through 3. We talk about analyzing the subgroup ranges chart, and items 4 and 5, the subgroup averages chart. And most of your statistical packages will have some other, you know, useful charts that you can look at. But the biggest, most important thing you can do is really kind of take notes and put stickies or observations right on those graphs to be able to document what you see. Quick review here. The subgroup ranges chart is looking at the variation, the range in those 3 measurements. And again, I circle that subgroup because that's the same operator looking at the same part, in this case 3 times. And so that dot represents the range, right? And then when looking at the chart, again, items 1, 2, and 3 in our graphical analysis, I want to see stability. So I should see no ranges above the upper control limit. That's a dead giveaway that we have a lack of stability. In this case, all looks good. Discrimination levels. We might want to call this resolution levels, right? Do I have granularity here? Do I have stratification of the data, or do I have a number of levels of discrimination? And I show it here because in my mind, this is what I'm doing. I'm kind of looking at unique lines or the strata, and I want to see a whole bunch of them, right? And I do count 0 as a possible. And if you remember from class, there's the formula, and I can use that formula. But for the most part, once I've drawn 5 lines here, I know I'm good to go, right? Repeatability independence, I want to see that there is no operator that stands out as being really high in their readings or extremely low. If, say, Syed's ranges were way down here below the green line, I might say, hey, Syed is showing that he can do it much better. The question becomes, why? Is Syed got a better process? How can he do that? We should share those best practices across the entire group of operators, right? And fix the process, get the process better. If there's potential for improvement, that's great. Next, we go into the subgroup averages chart. Just a quick review on the subgroup averages chart. This is the average of those 3 readings in my subgroup. So this is the between variation. And first of all, I would expect to see between variation in the parts, right? And I can also start to compare across those 3 different operators and start to look at their averages. Because basically right here, if I look at Karun's part 1, this is going to be his answer. It's this, hey, that's the size of part 1, right? Then he says part 2 is drastically different and larger than part 1. Okay, any questions on the averages chart? You'll notice I actually changed the titles in these so that when I'm discussing it with people, I can kind of point them to the right direction and talk about those charts. In Minitab, it's a little odd because they put the ranges chart above the averages chart. And we don't normally do that in normal control chart use. All right, so when I'm up in the averages chart, I'm going to look at item number 4 is part variation to measurement error. I want to see that the parts stick out, right? And from class, you may recall I say, do they stick out like a sore thumb, right? Those parts should stick out way above the repeatability noise band that we see here, okay? And then finally, item number 5 is reproducibility. The 3 operators, can they reproduce the results, right? And again, remember, we're trying to have an independent, the measurement system should be independent of the operators in this case, or of the parts. We might see an interaction where these part patterns actually look different for one operator, which means that particular operator might be interacting differently with the parts. Again, the part variation to measurement error for number 4, a lot of times a game I use is I call it the Lego game, right? Where we try to say, okay, if this is repeatability error, how many of these repeatability bands would cover my parts? And I'd like to see, 5 to 1. And you'll kind of remember if you use Minitab, one of the last things that Minitab puts in the session window session window is the what is it called? Discrimination levels, right? And that means how many of these unique bands could I put my parts into and classify them as medium parts, high parts, low parts, medium low. Again, we'd like to see decent discrimination ratios there. Oops, going the wrong way, I think. And we do have other charts here that we can look at that sometimes help us make a decision. The by operators box plot here shows me a mean for each one of these operators, that target value, and do I see those means all along the same line? Is there bias between an operator or not? And then the interaction chart is just like it says. I can see the operator by part interaction graphically, and I'm looking for differences in the slopes of these connecting lines. Basically, are these mountain ranges or patterns looking the same for all three operators? Okay, any questions? And finally, going back to kind of closing the loop on where we started off, talking about, why do we make measurements? I probably want to answer the question of, okay, how much variation, the gauge R&R percent of study, how much variation in my data am I getting from my measurement system? And that's this red bar here. And secondly, if I'm making decisions based on the tolerance or the spec limits, how much of the measurement system or how much of the tolerance is being consumed by the measurement system? And that's my yellow bar here. And again, you see I put kind of a 30% rule there. And in some cases, 30% is not good enough, but for the most part, we're kind of using 30% as the first line of discussion. And the next thing is the percent contribution. The little blue box is a variance calculation. So that variance calculation should be around 5% in my experience. It should be pretty low, like we see there. And we can compare this to the analytical output in the software session window. Now, the other thing is, if I want to use, there is the potential here for another bar if I were to enter the historical standard deviation of my product, and that might give me another, benchmark to look at and analyze my process. Okay, and we'll go into that in a later session, lunch and learn. Okay. And so just in closing, I'd like to say, hey, thanks for all your participation. In the spirit of continuous improvement, we're always trying to make these better. I appreciate from the prior session the feedback we got, and we certainly are using it and have used it for this session. But if you could go to this particular forums, and you won't see much new. Basically, it's start, stop, and continue kind of a format. But feel free to add any comments or talk to me on the side about any kind of feedback you might have, so we can improve this session or further future sessions.